I'm not actually going to work this problem, but I wanted to show what happens in this question. It's asking you to calculate probabilities when the sample size is 9 in part A, and then the sample size is 20 in part B and 32 in part C. Notice that when the sample size increases, the probability of it falling within that of it being less than 100 minutes gets larger. So what's important here to see is the average is 96 minutes. So as the sample size increases, the probability of it being less than 100 minutes also increases. And the reason is, with a larger sample size, the standard error of the mean is going to go down. So your sample size is going to get bigger, your error is going to get smaller, and the sample means are going to start falling closer to the population. So that's why the probability of observing a sample mean less than 100 seconds is going to increase as the sample size increases. So a few things to remember here. If the sample size gets larger, the standard error gets smaller. As the sample size gets larger and the standard error gets smaller, the sample means are going to be closer to the population mean. And so the probability of observing something that is close to the mean is the probability is going to be larger. In this problem, I'm not going to work all of this. I just want to look at part D just to review how to calculate probabilities of it being in between. So you have to calculate the standard error of the mean to get your z-score. And there is one problem on here, and I don't think it's this one. Let me look. Yeah, it's not this one. So once we get our z-scores, we're going to get our probabilities using Excel. So our average hotel price is $94.31. So I'm gonna let me erase all this really. And we know how to calculate the standard error of the mean, so I'm not gonna go calculate that again, but you can pause it and try to calculate it if you want to. It's 3.47. I'm gonna go straight to 92 and 94. Our values falling in between, our sample means falling in between 92 and 94. So you have to do the z-score for both. And we know the standard error of the mean is 347. And we know that, let's do the largest one first. And then let's see the smallest one over here. And then we know that we can use 94.31 because the sample size is large enough for the mean of the sample means. Okay, so we're going to calculate our z-score for both of these and round to 2 decimal places. Now I'm going to go put in both of these z values, and to get the probability of it being in between, you're going to take the probability of the smaller and subtract out the probability of the larger. Sorry, you're going to take the probability of the larger and subtract out the probability of the smaller. Let's do negative 0.09. And we want it to be cumulative. And then let's do the other one, which was negative 0.67. Okay. Oh, I forgot to put in true. Alright, so we're going to take the larger area minus the smaller, and we're going to get our probability. And it's 0.2117. and it may be that they rounded here. Or it may be, okay, it will take 0.2127. So that's how you find the probability of it being in between. That's not a new concept. The new part is the way that we're calculating our z-score in this chapter. We have to do our standard error of the mean.